Good morning all. Today we are going to discuss about the potential energy of a system of charges. So in the previous session we have learned that how to calculate the potential energy and how to calculate the potential at a point due to a point charge. So here we are talking about a system of charges are assembled and how we can calculate the potential energy of that system due to a number of charges. As per the definition, the potential energy of a system of two or more point charges is equal to the work that must be done by an external agent to assemble the system. That means for bringing each charge in its present position from the infinity. So if we have two charges at these 2 points, they are very close spaced charges at 2 points, and here for our convenience we are going to describe only two charges, a system of two charges first. So here these two charges are bringing here. So from where these two charges are bringing from the infinity. So these two charges we cannot bring at a time, and we will bring the charge one by one. So first of all we will bring a charge Q1. Q1 is brought here, and what will be the potential of charge Q1 at this point? And we know that from where this charge is bringing, the charge is bringing from the infinity. So we say that this is the infinity. From the infinity we are bringing the charge at this point. So the potential of the charge Q1 at this point will be 0. Why? Because the potential energy of any charge at infinity is 0. And while bringing here, this charge is bringing an empty space where there is no electric field. Okay, there is no electric field, so no work is done here. No external force is used to bring the charge from the infinity to the point. So therefore, the potential energy of that charge Q1 at this point is 0 here. And now the second charge is spaced at a distance R12. Okay, spaced at a distance R12, and another charge Q2 is brought at this point. And from this charge Q2 is brought, is also brought from the point infinity. Okay, but the difference is when the charge Q2 is brought at this point, so there is already another charge Q1, and this charge Q1 will produce an external electric field here. So we are bringing this charge Q2 under the influence of this electric field produced by the charge Q1. The same way when the charge is brought from the infinity, so at the infinity the initial potential energy of the charge Q2 is 0. As it brought to the point here, so the charge is bringing in the inside the electric field produced by the charge Q1. So a force must be used here. A force must be used to bring this charge Q2 from the infinity to the point here. So an external force is used, so there will be a work done. So, and the potential energy of charge Q2 at this point will be equal to that work done for bringing the charge from infinity to the point. Clear? What will be the potential energy of the entire system of these two charges? The entire potential energy of this system of charge will be the total work done for bringing this charge Q1 and Q2 at their present positions. These are the present positions of the charge Q1 and Q2, and both are brought from the infinity. So how much force is used, or how much work is done for bringing these two charges in their current position? That will be the total potential energy of that system. So what will be the total work done? So the total work done will W is equal to, so this is the W1 be the work done for bringing the charge Q1 from infinity to here, and W2 be the charge, the work done for bringing the charge from infinity to the point, its present position. So the total work done will be W1 plus W2. Okay. Then how we can calculate? So W1 and W2, how we can calculate the work done here? So in order to find out this work done, first we need to calculate the potential energy of the charges Q1 and Q2 respectively. So therefore, the potential of the first charge can be calculated. So as we know that the work done for bringing the charge Q1 to the current position, let's say this point A and B, to the point A, W1 is equal to 0. Then what will be the potential of charge Q2 placed at B? The potential B is equal to, as per the Coulomb's law, 1 by 4 pi epsilon 0 into, then what is the charge here? Charge is Q1 divided by, they are separated by a distance R. The work done in bringing the charge Q2 from the infinity to the point B, okay, against the electric field produced by the charge Q1, or we have learned that potential is equal to W divided by charge. So from this equation we can find out the work done. So what is the work done? The work done will be Q into the potential. So here we are going to find out the work done for bringing the charge Q2 from infinity to the point B, and that is taken as the W2. Okay. So therefore this equation can be rewritten as, we need to find out W2, that is equal to, at which charge we are bringing? The charge Q2. Okay. So Q2 V. And what is the potential? This is the potential here. So now we are substituting the value is W2 is equal to, then Q2 into, what is the value of B? 1 by 4 pi epsilon 0 into Q1 divided by R12. Okay. So that means 1 by 4 pi epsilon 0 into Q1 into Q2 divided by R12. That is the work done for bringing a charge Q2 from infinity to the point B. And now we have got the value of work done W2, and W1 already we know that is the work done for bringing the charge Q1 to the point A. That is already 0. We have already seen that. So therefore now the net work done, the total work done will be W1 plus W2, as we have already know, and W1 is equal to 0. Then again W2 is equal to 1 by 4 pi epsilon 0 Q1 into Q2 divided by R12. The electrostatic force is a conservative force. Therefore, these forces or the work done gets stored as the potential energy of that system. So that means the potential energy of a system of two charges Q1 and Q2 is, then we can rewrite this as, the potential energy is represented by U 1 by 4 pi epsilon 0 into Q1 into Q2 divided by R12. Now this is for two charges, and consider that there is one more charge, a number more than two charges. One more charge is bringing the same system of charge okay, or the same system, then how we can calculate the total potential energy of that system. So here see, consider the another charge here, okay, another charge here, that is Q3, and this charge also we are bringing from the infinity. But when this charge is bringing to the point C, okay, so there are already two charges, Q1 and Q2. So this charge must be brought into this electric field produced by these two charges, Q1 and Q2. So therefore, from this equation we know that the W1, the work done for bringing charge Q1 is 0, and again the work done for bringing the charge Q2 is 1 by 4 pi epsilon 0 into Q1 into Q2 divided by R12. That means W1 is W2 is greater than W1, and now we are finding out another one, considering a third charge which is brought in the electric field produced by two other charges, so that we need to use more force, so we need to use the more work for bringing this charge into the point C. So then the total potential energy of that charge Q3 will be greater than Q1 and Q2, of course, right? Then now see, let us calculate that. Now consider what is the distance between Q1 and Q3. This will be the distance that can be taken as R13, and from A and B and C, that is the distance between Q2 and Q3, taken as R23. Okay. Now we are going to calculate the potential energy of the system of three charges. How we can calculate it? So the rest of this, first we calculate the work done for bringing the charge Q1. Second, we calculated the work done for bringing the charge Q2. Now we need to calculate the work done for bringing the charge Q3. What will be the work done for bringing the charge Q3? That can be represented by W3 is equal to. W3 can be calculated as per this equation. Okay, here W2 is equal to Q2 into V. Then V12 plus V23. Okay, is equal to Q3 into 1 by 4 pi epsilon 0 into Q1 divided by R13 plus 1 by 4 pi epsilon 0 into Q2 divided by R23. Then 1 by 4 pi epsilon 0 can be taken out. Now what is it? Q3 into Q1. That means Q1 into Q3 divided by R13 plus, again this is taken out, then Q3 into Q2. That is Q3 into Q2 divided by R23. Now that is a value for W3. Now we need to calculate the total work done of the system. So as per the law, the total work done will be the total potential energy of that system. So therefore we can say that the total potential energy of the system U is equal to W, that is equal to W1 plus W2 plus W3. Then we know that W1 is equal to 0, again W2 is equal to 1 by 4 pi epsilon 0 into Q1 into Q2 divided by R12 plus, then what is W3? That is equal to 1 by 4 pi epsilon 0 into Q1 into Q3 divided by R13 plus Q2 into Q3 divided by R23. Then that is equal to total work done will be 0. Then what will be the 1 by 4 pi epsilon 0 can be taken as common. Then into what is remaining from here, 1 by 4 pi epsilon 0 is taken out, that is Q1 into Q2 divided by R12 plus, again here 1 by 4 pi epsilon 0 is taken out, then what is remaining? Q1 into Q3 divided by R13 plus, again Q2 into Q3 divided by R23. And this is the total potential energy of a system of 3 charges. That is the total work done for bringing these 3 charges into the